And also, as we know, this would be the angular bisector, so this angle becomes 60 degree, this also becomes 60 degree. 60, 90, 30. So this is very standard trigonometry rules that all of you should be aware of. What exactly is this 30, 60, 90 rule? So please understand this. Whenever you have a right, first of all, 30, 60, 90, as the name implies, is always a rule that is applicable for right angle triangles. One of the angles, as you can see, should be 90 degree. So the rule says, this is something that you can take note of. If you have a 30, 60, 90 triangle, then the ratio of the sides opposite to this 30, 60, 90 angle would be in 1:3:2 ratio. Which means, for example, if you just focus on this triangle itself, if the side opposite to this 30 degree is say x, then the side opposite, which means I am replacing 1 with x, then the side opposite to 60 would be √3 times of this, so √3x. The side opposite to 90 would be double of 30, so it would be 2x, right? So this is the property of the 30, 60, 90 rule that we have. So I hope you have taken note of this 30, 60, 90. Okay? So deleting this, coming back to the question again. So this was a triangle that we obtained in the 30, 60, 90 rule. And because this is an isosceles triangle, so this two sides being equal, so let me assume that this length is a. So this length would also be a. Now, the 30, 60, 90 rule says, what is a? This is 1:√3:2. So a is basically the length opposite to 90 degree. So this is a. Then what would be the length opposite to 60 degree? Just cross multiply. As far as these two things are concerned, if you cross multiply √3 into a by 2, what will be the length opposite to 30 degree? Just half of 90, so it would be a by 2, right? So this is some, so this would be opposite to this would be a by 2, this length, this height, and this would be √3a by 2. And because this is the median, so we can say the base would be of the length. If you double √3a by 2, and that is equal to √3a. So these are the things that we can conclude by the 30, 60, 90 rule. Now I think you've got all the sides of this particular triangle in terms of one variable. So you can easily find the perimeter in terms of that variable, find out the sum of three sides. You can equate that with 32 plus 16√3. So the sum would be a plus a, 2a plus a√3. So this perimeter, they are saying, would be equal to 2a plus a√3. Comparing, you can easily get the value of a should be equal to 16. Compare the rational term with the rational one, the irrational with the irrational one, right? So the coefficient of √3 is a, that should be equal to 16. And it matches here also. So a, the value of a is 16. So everything is obtained now. All you need to find now is the area of this particular triangle. Area of any triangle is what? Half into base. What is base? √3a. Replace a with 16, 16√3 into height. What is height? A by 2. A is 16, 16 by 2 would be 8. So that's equal to 64√3. And √3 is mentioned here. So in the box we will write 64. I hope this question is clear to all of you. So here we were using two concepts. One, the concepts of isosceles triangle, and second, in the second case, you could either use trigonometry, or I would suggest that you remember this 30, 60, 90. In CAT, you will almost encounter, if you would have required to use trigonometry in CAT, you will always encounter with predominantly right angle triangles of the form 30, 60, 90 or 45, 45, 90. Okay. So I think this would be the best approach as far as this question is concerned. But if you would like to have another or maybe an alternative method to this question, just to understand that you can always approach a question by various methods, only practice will make you realize which is the best method to solve any particular question. So you need not worry about the approach now. if you practice, I assure you that you will be able to approach questions also in a very efficient manner. Okay, so now I'm discussing an alternative approach to this question. When we have information about the angle, and also because two sides are equal, so basically you know this angle 120 and you know the length of these two sides. So can't we also find the length of this third side? Even if we are not aware of the property of isosceles triangle, we can use the cosine rule. I hope you have covered the cosine and the sine rule as far as geometry is concerned. By the help of cosine rule, if I know two sides and I also know the angle, the value of the angle between them, then by that logic I can find the third side. Let me just discuss that method. Again, you could proceed with the method that suits you, but just for an approach we are trying to discuss a different method. So first of all, let me tell you what exactly is cosine rule. In cosine rule, if two sides are known to you, say this side is A, this side is B, and the angle between them theta is known to you, then you can find the third side, say C here. The formula for the same is C square, the third side that we need to find out. C square is equal to, now once you have taken C, I mean this is what we need to find out. Now forget about this particular side, focus on the other two sides that we have. So C square is equal to A square plus B square minus 2AB, because this is cosine rule, as the name implies, cos theta. C square is equal to, now forget about this side, A square plus, everything has to be done with these two sides, A square plus B square minus 2AB cos theta, right? This is cosine rule. I hope you have taken note of this. So now coming back to the alternative solution for this particular question. This is a triangle in front of us where PQ is equal to QR. This is A, this is also A. To find QR, this angle is 120. So QR square should be equal to A square plus A square minus 2. A into A is A square cos 120. Now if you are aware of the basic concepts of trigonometry, then cos 120 is minus cos 60. Cos 60 is half, so minus half. So that would be equal to A square plus A square minus 2 into A square into minus half. So that's equal to 3A square. That's QR square. So QR would be equal to square root of this would be root 3A. That is what we had obtained. Then you can find the perimeter, you can equate this, you can get the value. That's it. So an alternative approach to find the third side. You can use this formula when you know the other two sides, length of the other two sides, and you also know the value of the angle between them. Usually that angle should be an angle that is computable, like 30, 45, 60, 90 or any multiple of that. And if you're not done with trigonometry, you can just simply take note of this. Cos 120 is equal to minus cos 60, and that is equal to minus half. Later on, when you're done with this topic, you verify my statement which is mentioned here. Right? I hope this question is clear to all of you. So let's move on to the next question. It's a question on angles. Again, you should get this answer. All of you, please try. Note down the question, draw the diagram and try. Okay, I hope you have read the question. I hope you have read what's the constraints here. CD is the diameter. So the angle property that I'm trying to use here is, I hope you are aware of this property. In case of a circle, if you have a diameter, that diameter would always subtend an angle of 90 degree at any point on the circumference, any point, whichever point you take on the circumference, the angle subtended would always be 90 degree. Now here in this, it's clearly mentioned that CD is the diameter, this angle is 40. What you need to do is find out the sum of these two angles which I have marked. Now because this is the diameter, so the angle subtended by this would be equal to 90 degree, yes or no? Correct? We are done with the question. We have got the answer. Just one step I need to dictate to you. I hope you are also aware of the property that any cyclic quadrilateral, what is a cyclic quadrilateral? A quadrilateral for any four-sided figure whose vertices lie on the circumference of the circle. Any cyclic quadrilateral has this property that opposite angles are supplementary, which means their sum should be equal to 180. So this ABCD being a cyclic quadrilateral, the sum of angle A plus angle C should be equal to 180, yes or no? Now in A plus C, we know the value of this angle, which is 90 degree by the property that we just saw, and this is 40 degrees. So 90 plus 40 adds up to 130, which means the remaining two angles should add up to 50 to get the net sum as 180, right? The sum of angle A plus angle C. So angle A is comprising of 90 degree plus you take this as X, and angle C is comprising of 40 plus Y. I hope you understood the question. You need not write this equation. These are things that you need to do away with. You need to visualize the question and get the answer orally. So anyway, 50 would be the correct answer to this particular question. Right? Is it clear to all of you? Please take note of it quickly. Okay, next question. Very easy question. Please try a few. I'm sure that you must be aware of the formula for the number of diagonals. Try to plug in the formula and solve this question. Just to give you a hint, if anyone is not aware of, or if you do know, tell me the formula, please, all of you. What is the formula for the number of diagonals of a regular polygon? So the number of diagonals of a n-sided polygon is given by the formula. Please mention me the formula. Yeah, n into n minus 3 by 2. This is the formula to get the number of diagonals. That's the only hint I would like to give you. Now please read the question, complete the statement, you will get the answer straightforward. It's a very easy question. Yeah, so the number of diagonals, as I have mentioned here, is 3 times the number of sides n. So from here you can straight away cancel out n and you get number of sides as 9. So this is a 9-sided polygon, regular polygon, please note. That's why you need to find out the measure of each interior angle. Now to find the interior angle, again if you wish you can use the formula for the sum of interior angles and get the answer easily. But again, try to visualize the question, try to get the answer orally. Rather than, instead of using the property of interior angles, let's concentrate on the exterior angles. What is the sum of all the exterior angles of n-sided polygon? Irrespective of the number of sides, we know that the sum of exterior angles is 360. So 360 is the sum of exterior angles, divide by 9. This is a 9-sided regular polygon, so each exterior angle should also be equal like each interior angle. So 360 by 9 is 40 degree. That's each exterior angle. So each interior should be 140, right? So you should get the answer orally. You need not spend time writing down those steps. Please note in CAD there is no step markings like you had in school, right? So 360 being the sum of exterior angles, I divide by 9 because we already obtained that this polygon has got 9 sides. So each exterior angle is 40 degree. So interior angle can be obtained by subtracting 40 from 180. So 140. Moving on. Next question. Isosceles trapezium. What is an isosceles trapezium? In trapezium, we know that there are 2 parallel sides and these are called oblique sides. An isosceles trapezium is a trapezium where 2 oblique sides are equal in length. Okay, that's what is the definition of an isosceles trapezium. Now please read the question, decipher what the question is trying to say, and make the basic diagram if required. Okay, so I hope you have read the question properly. So we have got an isosceles trapezium, which means if AD is 5, BC would also be 5. That's the definition of isosceles trapezium. The oblique sides are equal, and because of that, the property that we have is if we drop perpendiculars here, obviously if AB is x, this part would also be x, and because this is an isosceles trapezium, this length would be equal to this length. If this is y, this would be y. Now see, one way of, again, as I have been repeatedly saying, the instant solution that we always find is making equations, solving them, but geometry is a very beautiful topic where you can visualize the numbers. You can straight away see the solution or the answer in front of you without going further into solving the questions. Now when they are saying that the difference of the length of the parallel sides is 8, difference of the length, obviously the longer side, which is the bottom side here, CD, should be 8 centimeter more. And where should that extra 8 centimeter come from? This is equal to this part, right? So that extra is these two only, and they should be equal. So if it is 8 centimeter more, do I need to further explain and mention it to you that these two should be nothing but 4 and 4? That's it, you're done with the question. This is a right angle triangle, 5, 4. What's the triplet that is striking here? That's nothing but 3. 3, 4, 5 is a very standard Pythagorean triplet, right? So find the height of the trapezium. That's it. This is the height of the trapezium. 3 centimeter would be the required answer. Now because I have used this word here, Pythagorean triplets, I would like to also go ahead and mention few of the Pythagorean triplets. Please take note of it. See, just from your preparation point of view, if you observe the last 8 to 10 years CAT papers, most of the questions, approximately 60%, 65% of the questions of geometry were from triangles, were from the topic triangles. And out of these questions from triangles, 70%, 80% of them were concerning the concepts of right angle triangles. Right angle triangles, the only thing that strikes here is Pythagoras theorem, Pythagorean triplets. So these are this is a very important concept that you need to be well versed with. Having known Pythagorean triplets, sometimes when you look at a right angle triangle, you can straight away plug in the values and you can understand that this is the right angle triangle that they're talking about. So what I would like to do now is, I would like to mention few of the points as far as right angle triangles is concerned. Currently, let me confine myself to Pythagorean triplets. So all of you please take note of few Pythagorean triplets that I am talking about. This question is done. This answer here would be 3 centimeter. So I am erasing this part, the solution here. And note down Pythagorean triplets. So what I am trying to tell you is, please memorize these Pythagorean triplets. So let's start with some of the triplets starting with odd numbers. There are tricks in which you can generate these Pythagorean triplets, but those are from CAT point of view not very important. The important part is that you know what is a Pythagorean triplet. So when you come across 3, 4, you know that the hypotenuse has to be 5. 3, 4, 5 is the standard Pythagorean triplet. Then starting with 5, we are generating Pythagorean triplets starting with odd numbers. So from 3 we have 3, 4, 5, from 5 we have 5, 12, 13, 7, 24, 25, 9, 40, 41, 11, 60, 61. So just take note of this. You should memorize these Pythagorean triplets. If you come across a question in CAT where you have to solve for this, say, right angle triangle where this side is 9, this side is 40, to calculate the hypotenuse, if I find you calculating the hypotenuse as root over of 40 square plus 90 square, I would be very upset. You should not calculate this by using Pythagoras theorem. You should know that a 940 right angle triangle would have 41 as a Pythagorean triplet as a hypotenuse. So this is something that you need to memorize. Let's look at some of the Pythagorean triplets starting with even numbers. See, there are infinite Pythagorean triplets. It's good if you can memorize further, but this is some standard Pythagorean triplets. Predominantly 90% of the Pythagorean triplets would be revolving around these numbers. You simply memorize them. So starting with even numbers, we have got 6, 8, 10, 8, 15, 17, 10, 24, 26, 12, 35, 37. So these are the list of Pythagorean triplets which you need to memorize, and that's a request from my side. This will help you. You will understand the importance of this when you try solving questions based on right angle triangles. We'll have a couple of questions based on these triplets in this handout also, which we'll try to see. That time I would not revisit this concept again, so you please take note of, just write down these Pythagorean triplets and memorize them when you get time. Right? I hope this is written down by all of you. So let's move on to the next question. There are other concepts also in right angle triangles which I'll explain if we come across any question related to that concept. Okay, question number 5 now. It's a question on angle. Please draw the diagram. Look at the constraints, try to solve it. Okay, done. Have you read the question properly? So here we have got DB and DC being tangents. Okay, fine enough. And angle BDC, it's mentioned to be theta. You need to find BAC, and as you can see from the options, you need to find the value of BAC using in terms of theta. Okay, so I'm straight away getting the answer. You would also, I hope you're aware of this particular theorem as far as the angle properties are concerned. Alternate segment theorem. Take note of it, please, as and when I explain this part. Alternate segment theorem. This is a very, very interesting angle properties with regards to circle. So what is this theorem all about? If you have a circle and there's a tangent drawn to the circle. There's a tangent drawn to the circle. So that tangent, obviously, that's the property of a tangent. It would touch the circle at one point. So that point of contact, let that be, say, P. From that point of contact, you draw any chord. From that point of contact, say we drew chord PQ. So this property says that the angle that this chord makes with the tangent, say theta, would be equal to the angle that this same chord subtends at any point on the circumference. So this would also be theta. This is the theorem. If you would like to take note of it, please, I am dictating the theorem. Please, all of you, draw this small diagram on circle and just note down the theorem. The angle made by a chord, please write it down, the angle made by a chord with the tangent, the angle made by a chord with the tangent at the point of contact, at the point of contact. So angle of the chord with the tangent at the point of contact is same as or is equal to the angle subtended by the same chord is equal to the angle subtended by the same chord at any point on the circumference, is equal to the angle subtended by the same chord at any point on the circumference. If you are curious enough to know the proof of this theorem, I'll just proceed with that also because it's a very easy proof. Now, I hope you all know that from the center of the circle, let this be the center, if you connect this to the point of contact, this angle is 90 degree, yes or no? Which means if this is theta, so this angle becomes 90 minus theta. Likewise, if I connect the center with the point Q, this angle would also be 90 minus theta. Why? Because these two sides are equal, radius of the circle, so the opposite angles would also be equal. Now you can easily obtain the central angle here. You subtract from 180 these two angles, 90 minus theta plus 90 minus theta. This 180 gets cancelled out, so this is 2 theta, this central angle. And now I hope you are aware of this interesting angle property of a circle. If a chord or an arc, as you might say, if a chord subtends an angle, say 2 theta at the center, then this same chord will subtend an angle half at the circumference, and that's equal to theta. So this is the theorem. I tried to show you the proof. My objective was just to make the concepts clear. If you understand things with proof, you will never forget it. So this is all about alternate segment theorem. Now applying this alternate segment theorem here, please pay attention, all of you, please. This is a chord which is touching the circle at a point where the tangent touches the circle. So basically this is a tangent. Let's extend this. This is a tangent, and at this point where the tangent touches the circle, you have drawn a chord. So by the theorem that we just learned, if this angle is say x, then this angle which we need to find out would also be x. Likewise, we have a tangent here also. So if this angle again should be x, because this angle by the same theorem should be equal to this angle, right? So can I say that this angle would also be x, right? Which means these two angles are equal. Is it clear? If these two angles are equal, can I say because this forms BCD forms a triangle. I tried to shade so as to understand that what we are trying to do here. So BCD forms a triangle, so sum of all three angles should be equal to 180. So can I say 2x should be equal to 180 minus theta, or x is equal to half of this 90 minus theta by 2. That's x. That is what we were supposed to find out. This is how quickly and easily we can get the answer to this question. Now please understand, you might also get this answer in a different way, one step more, but this is all about practice. Please do not be afraid if you are not getting any single question here. All you need to do is back up your concepts, revisit them again and again, get done with the concepts properly, go through the concept review questions, and then keep on practicing. Things will improve over time, right? So this would be the answer. Option D would be the correct answer here. So shall we move on to the next question? Yeah, question 6. Have a look at this question. Please take time and read the question properly.